Pleasure to be here. Thank you for the invitation. So I've been asked to give a about 45 minutes webinar, leaving a lot of time for questions at the end, about how we can and how we probably cannot use routinely collected data for conducting palliative care research. To make things simple, I'm going to use a classification made by Miguel Hernan at the University of Harvard. He basically says that with data we can do three different things, and a lot of the problems that we've got today are actually very often self-inflicted injuries. So the first one is when we describe what is happening in the world, we want to make a quantitative summary of certain features of the world, and we confuse that with prediction purposes. So prediction is simply trying to make a link, a correlation between a certain amount of things that we observe and try to forecast what could happen in the future if the same set of circumstances. Goal with the idea of making causal inference, that is, trying to see how the world would have looked like if things had been different. And I'm going to go through each of these three. Etc. But the goal is always to describe what we see. It's not about making predictions, and it's certainly not about trying to make any kind of causal claims. Another very classical topic is that of trying to understand or trying to measure the level of aggressiveness of care, the level of overly aggressive care among cancer patients. That's the Beckelman paper published in the JAMA. This is a study we conducted in France using about 500,000 people's records, electronic health records. And more recently, some of our colleagues in Belgium have been trying to develop quality indicators that can be used not at the patient level, but at the geographical level, to try to see whether within a certain country or a certain set of countries, we can use indicators based on routinely collected data to judge whether or not certain healthcare systems are maybe too prone to provide certain types of treatments at the end of life. The same has been done, and that's again from Joan Tino and her team, the use of advanced, of tube feeding among people, among nursing home residents with advanced dementia. And it's again the same thing, is trying to see whether things have changed or not over time. More recently, we have been applying the same idea to try to look at not only the use of overly aggressive care in cancer, but the prescribing of potentially inappropriate or potentially inadequate drugs at the end of life. That's, for example, a study that we did a few years ago in Sweden, again, using about 500,000 people's health electronic records. So that's several billions of drug prescriptions. And we looked over time at how the proportion driven by the onset of symptomatic medications, but it's mostly driven by the. So we have a challenge now to try to bring a field of descriptive studies that do not only look backwards from death, but also try to prospectively map out what are the main features of people's end-of-life trajectories. And part of that issue will have to do with trying to predict or to provide algorithms and data that allow us to forecast what is most likely to happen. You could think in terms of movie of this Minority Report movie that came out more than a decade ago now. The idea is, contrary to description, is to try to take the data that describes the world and try to figure out how we can make the best use of that data, how we can make use of the past to foresee the future, Of course, a classical example would be that of building prognostic indices, but more and more people are moving towards using latent type of analysis, for instance, deep neural networks, to foresee or to predict potential complications, especially in the field of intensive care. And that has been published in the Lancet Respiratory Medicine about a year ago, is trying to use all the trove of data that all of us are collecting in the hospital on a daily basis to try at the time of admission to predict the risk of severe complications in critical care. There is right now an arms race. I know she is not there because she couldn't join us, but there is an arms race between a very strong group at Stanford University and another one at Dana-Farber and Harvard, trying to harness the power of especially natural language processing. So trying to use not only the structured data, but also very unstructured, messy data such as discharge letters, to try to understand who has had conversations about end-of-life care goals, who would be at risk of receiving overly aggressive care, etc. And one of the persons leading that field is Charlotte Lindvall at Harvard Medical School. And the idea of predictive studies, for those of you who are not familiar with it, is to try to take some of the input that we have in the data to predict an unknown risk. And it's actually not rocket science. It's about ordering and weighting these different data points. It's about trying to understand how much importance we need to give to the different data points so that it makes an accurate prediction of what's most likely to happen in the future. Now, how would that be relevant to improve end-of-life care? It is very fancy and often a little bit sort of mind-boggling, but it actually also could be interesting and important to improve, I would say, bedside practice in palliative and end-of-life care. Well, the first application is quite obvious. It's about risk stratification. It's about trying to give, for example, GPs or to give internal medicine physicians at the time of admission a very good estimate of how likely a certain person is to have some pulmonary embolism or some sepsis or an episode of delirium, et cetera, et cetera. And if we could stratify in advance, in a time frame that is compatible with advanced care planning and with preventive measures, people according to their risk of having some adverse event, that could actually be a game changer. The second field of application would be that of improving the accuracy of diagnosis. That is especially true in the field of oncology, and the accuracy of prognosis. To be honest, the past few years have been quite disappointing in the latter field. Although we have a lot of data available today, we do not have yet good models enough to predict prognosis beyond a 75 to 80% accuracy, which means that we're still, even with the best data we can get, we would still be missing 1 out of 5 people. We would be incorrectly assuming the survival time of 1 out of 5 patients in a substantial way. So this is definitely something to look for in the future. But right now, people who are promising that they can accurately predict the remaining survival of seriously ill patients are basically overselling their findings. The last sort of field of application is a little bit more low-key. It's about refining target populations for our interventions. There is a very nice paper that came out in the Journal of General Internal Medicine about 3-4 months ago. It's about trying to use electronic health record and to use latent statistical analysis to try to find out who would be the people that are the most likely to benefit from a targeted palliative care intervention in the hospital. And that is definitely a fantastic field of innovation in the next few years, because right now a lot of randomized control trials and a lot of interventional studies or innovation initiatives have sort of hit the wall when it comes to identifying the right target population. So the idea here is that predictive modeling or predictive studies are not the end game. They're actually just a step to allow for a more full-blown research initiative later on. Another application, still in this idea of trying to target the right people at the right time, is to try to map and to understand in advance what is the most likely frailty trajectory of functional decline, especially of people as they near the end of life. And here, Daniel Stowe at the University of Newcastle in the United Kingdom has been paving the way, showing that with enough data and with a well-selected enough population, there is the possibility of anticipating and forcing, predicting who would be the people at the most risk of rapidly rising physical frailty. Now, trying to say that we are using certain features of the world and we are trying to link them to what could happen in the future is not the same thing as drawing a causal conclusion. In the work of Daniel Stowe, which I just showed you about, trying to predict frailty, it's not about trying to say that the inputs that allow us to foresee frailty are the cause for the frailty. It's simply that, although we don't really understand it completely, there is an observation that these are good predictors. But again, it's not about trying to establish a causal relationship, because the thing of a causal relationship, and I guess for those who have a Netflix subscription, you will be familiar with Westworld, it's about trying to understand or to guess how would the world have looked like, or how the world that we see differs from the world that we would have seen if things have been different on one key element. It's about trying to understand if the world that we see has a certain feature that is set at 0, how would a world with this feature equal 1, how would it differ from the world that we actually see? And the gold standard for doing so is usually assumed to be the randomized control trial, because randomization allows to answer that very important question whether on average, and the key word here is on average, whether on average a certain intervention can improve the quality of life of patients with advanced illness. So it's not trying to establish a causal relationship for each and every single patient that actually receives the intervention. It's trying to see whether on average the group of people who receive the intervention does better than the group who doesn't. And we can apply that kind of reasoning, of course, to treatments, especially drug treatments. I guess that's the most common scenario, but also to models of care or policy changes. And very good applications of that outside of randomized controlled trials, often because it's either practically unfeasible or ethically challenging or unacceptable, are the paper by Pedro Gonzalo in 2015-2016 in New England, trying to understand, would the Medicare cost at the end of life had been different in 2009 if the hospice care in nursing home had not taken place, basically. And that is, of course, something that we cannot randomize retrospectively. The other example on the right side of the screen is a paper published by our colleagues in Belgium, in Brussels, is to try to understand whether palliative home care support can indeed improve the quality and the cost of care at the end of life. And for many reasons, doing so with a randomized at the most risk of rapidly rising physical frailty. Now, trying to say that we are using certain features of the world and we are trying to link them to what could happen in the future is not the same thing as drawing a causal conclusion. In the work of Daniel Stowe, which I just showed you about, trying to predict frailty, it's not about trying to say that the inputs that allow us to foresee frailty are the cause for the frailty. It's simply that, although we don't really understand it completely, there is an observation that these are good predictors. But again, it's not about trying to establish a causal relationship, because the thing of a causal relationship, and I guess for those who have a Netflix subscription, you will be familiar with Westworld, it's about trying to understand or to guess how would the world have looked like, or how the world that we see differs from the world that we would have seen if things have been different on one key element. It's about trying to understand if the world that we see has a certain feature that is set at 0, how would a world with this feature equal 1, how would it differ from the world that we actually see? And the gold standard for doing so is usually assumed to be the randomized control trial, because randomization allows to answer that very important question whether on average, and the key word here is on average, whether on average a certain intervention can improve the quality of life of patients with advanced illness. So it's not trying to establish a causal relationship for each and every single patient that actually receives the intervention. It's trying to see whether on average the group of people who receive the intervention does better than the group who doesn't. And we can apply that kind of reasoning, of course, to treatments, especially drug treatments. I guess that's the most common scenario, but also to models of care or policy changes. And very good applications of that outside of randomized controlled trials often because it's either practically unfeasible or ethically challenging or unacceptable, are the paper by Pedro Gonzalo in 2015-2016 in New England, trying to understand, would the Medicare cost at the end of life have been different in 2009 if the hospice care in nursing home had not taken place, basically? And that is, of course, something that we cannot randomize retrospectively. The other example on the right side of the screen is a paper published by our colleagues in Belgium, in Brussels, is to try to understand whether palliative home care support can indeed improve the quality and the cost of care at the end of life. And for many reasons, doing so with a randomized control trial would prove very difficult, especially for power problems that we need to include to detect small changes, to include a considerable number of people, and that proves to be often financially prohibitive. So these are just two examples, pretty well done, of studies that have tried to sort of mimic what would have been a randomized experiment if one could have been conducted, but this time using not experimental data, but observational data. Now, why is it so difficult, and why even these two very good papers have shortcomings? The first one, I guess, is very obvious, is the looming threat of confounding by multimorbidity. So it's confounding by indication, which is a very common threat in epidemiology, multiplied by the power of 10. Because if you look at people at the end of life, in the last year of life, if you look at a Medicare compatible population, so 65 plus with a serious illness, you would say that during the last year of life, for each additional chronic disease, you would observe an additional drug on average, which means that if you want to disentangle the effect of each additional drug or each additional treatment on the outcomes of these patients, you need to account in a very refined way for the burden of multimorbidity. And that proves to be very complicated in observational data, especially when you consider the second graph showing for community dwellers and nursing home residents, the distribution of multimorbidity in the population, is that for most of these chronic diseases, you need exceptionally good data to capture symptoms, to capture clinically thin and non-expressive, clinically latent chronic diseases that could actually have an importance for the quality of life of patients, but that would not necessarily be reported in the data. If you take in Sweden the prevalence of heart failure in the population during the last year of life, so about 39%, you would see that 70% of these people with heart failure have at least 6 other chronic diseases on top of heart failure. So trying to understand from observational data whether continuing or discontinuing ACE inhibitors has a benefit or comes with some kind of harm for these people with heart failure would actually be very challenging, simply because first, you don't really know if the ACE inhibitors have been indeed prescribed for heart failure or for another indication. And second, because in addition to the potential, let's say, side effects of ACE inhibitors, you would expect a lot of disease-drug interactions that could also explain these adverse effects. So that's the confounding by multimorbidity problem, which is of course a confounding by polypharmacy problem and a confounding by symptom problem. Which means that as long as we do not improve in a substantial manner the routinely collected data that all of us have access to, in the US, I guess one very common source of data would be Medicare, parallel group designs, trying to compare different groups across each other, will prove, at least for the next few years, extremely challenging in the setting of palliative and end-of-life care. There is a potential workaround, and that is under development right now, is to try to use self-controlled or hybrid design. So instead of comparing group A and group B, it will be about trying to compare group A before the intervention and group B right after. So the idea is to use people as their own controls, assuming that time non-varying confounders will be sort of taken care of by design. Now, the problem of self-controlled designs is that by nature, you cannot look at adverse outcome that cannot reoccur over time. So death is off the table, which is a big problem because a lot of us are interested in trying to measure interventions that potentially could postpone or avoid early mortality or avoidable mortality. The second problem of this approach of causal inference using observational data is actually the same as in randomized trials, is that to provide answers that help patients, we need to ask questions that matter. to make a parallel, I took this cartoon from 18th century French cartoonist Lumière, and he says, well, gentlemen, this operation that was said impossible yet succeeded perfectly. And the attending said, well, doctor, the patient is dead. What does it matter? She would be much more dead without the operation. And beyond the cartoon, I think there is some truth to this, is that we need to make sure that in the context of serious illness and end-of-life care, we are asking and trying to frame questions that make sense for the patient. And here we have sort of hit the wall, because a number of clinical trials have proven very effective for the intermediate endpoint, but not for the final endpoint, that is the end game. Two examples of that are very well conducted randomized clinical trials. The first one by Randall Curtis at the University of Washington, trying to understand whether a patient clinician communication priming intervention could actually improve patient outcomes. And the results of that trials are very exciting, because they show that a very simple intervention and very non-costly intervention can substantially increase patient-reported goals of care discussions, but that does not translate, unfortunately, and that's the disappointing part, that does not translate into a meaningful improvement of their quality of life or well-being. The second example, outside of the field of end-of-life care, is the 3D trial conducted in the UK, published last year in the Lancet, and it was about trying to use a patient-centric care model to improve the management of older patients with multimorbidity. And again here, a lot of indicators were seriously improved with the 3D approach, including better satisfaction with care, better coordination, better care pathways, less transitions, etc. Patient satisfaction did increase a little bit, but all the clinical endpoints actually remain very stable. So there is no decrease in polypharmacy, there is no decrease in adverse event, there is no decrease in mortality, there is no decrease in potentially iatrogenic consequences. And what these two trials show us is that sometimes the interventions that we think will work are actually only having an effect on the sort of middle ground and not on what we're really trying to improve. And that, I guess, comes also with the selection of the target population. The problem of randomized controlled trials and the problem of observational studies that we try to mimic randomized controlled trials a little bit too close is that they tend to make us believe that all the men in the world look like this gentleman, and I'm very afraid to say it's not the case. If we do things right, we have a chance of actually believing that all men in the world look like this chap. And again, although it's a little bit more realistic, it is still not the case, because the person that we are really looking for is this third man on the right. And in a lot of randomized controlled trials, they are missing from the field, and we are criticizing RCTs quite a bit for that, because then there is a problem of external validity. But more and more observational studies using big data are actually sort of falling in the same trap by trying to exclude outliers and by selecting cleaner, so to speak, populations, trying to select more homogeneous populations. They also tend more and more to actually leave out the persons that we are the most interested in, that is the oldest, the frailest, the most vulnerable, the most multimorbid, and the most polymedicated. So the question we need to ask ourselves going forward, and especially using big data, is what are the patients that are the most likely to derive a meaningful benefit from any kind of intervention? And to answer that question, we need to ask the first question first, is what constitutes a meaningful benefit? And here we, I think, have some grounds for concern coming from UCSF, a paper published in 2017 in the JAMA Medicine, trying to look at the association between beta blockers and functional outcomes among older nursing home residents after acute myocardial infarction. That is a study based on big data, and the very interesting results of that study, for those of you who do not know that study, is that yes, beta blockers after myocardial infarction are very beneficial to postpone mortality. However, they come with some serious harm when it comes to functional decline, especially, and that is where this study was the most sort of alarming, especially for those people who, at the time of discharge back to the nursing home, were the people with the worst ADL functioning and the worst cognitive performance. So those who were already the frailest after initiation of beta blockers tended to have a faster pace of functional decline. And the question that study raised is, what do these people really want? What do they think is a meaningful benefit? How many of these people would actually accept a trade-off of quicker mortality and less likely functional decline? And some qualitative studies actually suggest that a substantial share of older adults with significant functional impairment and like limited life expectancy would actually prefer a therapeutic strategy that sort of puts the priority on ADL maintenance, even if that comes at the cost of earlier mortality. Now, can we measure what matters for the patients in routinely collected data? In most cases, we can't. And that means that until we actually have patient-reported outcomes and patient-reported preferences in these massive routinely collected data warehouses, it's going to be very difficult for us to measure the impact, the influence, the effect of interventions in populations that are at the end of life in a way that allows us to bring answers that will eventually help these patients. The risk otherwise is that we provide answers that are methodologically very sound, but from a content point of view, make little sense for the patients who actually are at the core of our question. Another problem that we are having right now, and that is under discussion in a lot of research units, is the problem of time zero. I will take for that the example of statins. So Jean Kuttner and Ami Abernethy, among others, have shown in the statin discontinuation trial that if you select people with less than a year of estimated life expectancy, discontinuing or continuing statins has no or very little influence on the remaining survival. But the problem is that if we do that with observational data, if we look at people who are using statins, and at some point we compare those who continue and those who stop, we're going to end up showing or believing that those who continue statins live longer. And the reason for that is that, well, the prescriber who decided to continue or not to continue statins probably did so anticipating the remaining survival. And some colleagues of ours with Emelson, and again with the team of Miguel Hernan, has shown that if you do things the right way, and if you use a very stringent study protocol, trying to mimic what would have been the randomized control trial doing that, you end up showing that there is absolutely no survival difference among cancer patients who discontinue or continue statins. It's actually, again here, a self-inflicted injury, which comes from bad designing, and that has again been shown a few weeks ago in this very nice Nature Medicine paper, that looking at the influence of statin continuation or statin initiation on the onset or the survival with cancer is a very tricky question to answer with routinely collected data. It is possible, but it raises the question of when should we start considering that people that we see in these massive data sets are at the end of life and maybe discontinue statins because they are at the end of life and not the other way around. That is exactly the same problem when you look at this paper from Claire White and colleagues in The Lancet about a year ago, looking at whether or not it could be worth it to actually provide thromboprophylaxis for cancer patients admitted to specialist palliative care units. Well, Claire White, by using ultrasonography, showed that a massive amount and massive number of patients are admitted to specialist palliative care units with deep vein thrombosis that no clinician had actually spotted. So if you try to do the same thing without using a very clean and a very systematic way of diagnosing deep vein thrombosis, those that you will capture in electronic records are the most symptomatic and severe cases. And if you try to compare them to people for whom no thromboprophylaxis would be provided, you would end up mixing pears and apples. And that's fine to mix pears and apples as long as you want to do a fruit salad. If you want to do epidemiology, that's a very bad idea. And of course, the final problem that we are facing now is how do we account for the competing risk of death? The fact that, for example, if tomorrow we're able to investigate the benefit and the harms of, for instance, initiating novel oral anticoagulants for people with atrial fibrillation, how would we take into account the fact that a substantial number of people with not only atrial fibrillation, but let's say cancer or heart failure or stroke, well, a number of these patients would never actually either get the harm or experience the benefit simply because they would die before the drug can actually kick in. So that's another methodological problem, is that in the population of people at the end of life, well, of course, death can sometimes simply come in the way of us observing whether people could have benefited or could have been harmed by the treatment or by, let's say, the model of care that we're trying to provide. Before ending the presentation and taking your questions, just a quick reminder for those of you who haven't seen it before. I have the pleasure to be a co-guest editor with Brejo Onmutika Philipsens from Amsterdam, to be the co-guest editor for Palliative Medicine. We're going to have a special issue on big data in palliative care, and the deadline for submitting papers is the 17th of April 2020. So please, if you have papers in the pipeline, if you have ideas, if you want to submit papers, it can also be more methodological or reflexive papers. They will, all of them, be very welcome. Thank you very much.
Thank you so much, Lucas, for such a great presentation. We have plenty of time now for question and answers. I just want to remind you all to please use the Q&A feature at the bottom of your screen, and we will happily answer questions as it We'll wait a few minutes for you all to type in your questions. All right, I see one question from Connie. Do you think building more qualitative approaches into quantitative data collection methods with big data would help to address what is important to the patient and their families? Lucas, how do you feel about that?
I'm very sorry, but your connection seems to be a little bit flickery. I only could catch the end of the question.
Okay, let me know if you can hear me all right. Do you think building more, okay. Do you think building more qualitative approaches into quantitative data collection methods with big data would help to address what is important to the patient and their families?
That's a very good point. It would certainly help in sort of separating the wheat from the chaff and trying to understand whether what we are measuring is most likely what people are sort of paying attention to. I would say the main problem of that approach is that people who agree to participate in qualitative research, especially in this very peculiar time of their life, are probably highly selected. So the question is, when we do qualitative research, and I do see a lot of value in it, but when we do qualitative research with people with serious illness and severe symptoms and limited life expectancy, how much selection bias would we expect? And how would we feel about the generalizability of these findings? And I think this is a concern that has not been addressed so much in qualitative research.
Okay, thank you for answering that question. Now, as a pediatric end-of-life researcher, we lack many of the data sources available for adults, and patient-reported outcomes may be extra important in pediatrics. How do you suggest we work on building the infrastructure for big data research in pediatrics?
Well, I guess here it's going to be a very sort of country-specific approach. So I'm working in Sweden, and in Sweden we do not have the split that you have in the US, especially when it comes to Medicare. So it's a universal healthcare system. So we actually have data for the entire population regardless of age. And when it comes to patient-reported outcomes, so you have a few so-called quality registers focused on specific themes. One of them is a pediatric oncology register, where they actually get an immense amount of information about the parents and about the siblings. So I guess that's one way to do it, is to try to build an infrastructure that is specific to a specific topic. Then, of course, that comes with some challenges, because you don't only want to have a large population, you also want to have very in-depth information about everyone. But I guess one approach would be to do that. The other would be to look at a very selected population, let's say with a very specific disease or a very specific set of conditions, and to start from there to identify these children and their families, and to actually, because then we would be talking about, I would say, a few hundreds or a few thousand people, to actually use then very classical surveys. Given the size of the population, I fail to see the real advantage of using big data over more traditional tools. So big data could be a very nice way to actually build a sampling frame or build a survey frame. But then relying only on routinely collected data, I think would be underusing or under investigating the topic.
Thank you. Those are excellent points. We have another question. Are there key benefits of the current research paradigm over the big data paradigm approach, how the big data science is shaping to overcome any limitations?
I know, so big data is certainly not coming or gonna overcome the rest of the field anytime soon. I guess, so you have a few advantages. The main one is how easy and flexible and immediate it is to answer, or at least to get into answering research questions. If you have access to this type of data, you can very quickly discard, or on the contrary, confirm the interest of certain research questions. So that's, I guess, one of the key advantages. The second key advantage is that if you have the right data, and you certainly do in the US for many topics, you can actually get to investigate populations that would either not be eligible for RCTs, or that would refuse, or most likely refuse, to participate in surveys or in qualitative research. One example of that will, of course, be, and that was proven recently, people with end-stage kidney disease who are not eligible for dialysis. That is a population that, if you read the literature, does not exist. Another example is people who end their life in prison. And that is certainly a massive population, especially in the US. And that is a population that, again, if you look into PubMed, these people seem to not even exist. And yet they are there, they have considerable needs. So if you have the right data, you can actually look at certain subgroups without having to sort of obtain access to them. So that's a very good thing. Now, the main disadvantage is, of course, the lack of randomization. So you never know, when you make a link between a treatment or an intervention and an outcome, you never know if the threat of confounding is too big to be overcome, or if you have ways to work around them. So I guess that's one of the main challenges. And the other challenge is, as we just said, we still have a lack of patient-oriented or patient-reported outcomes. So what we can measure is certainly of great interest, but quite often I would be very doubtful that as whether patients themselves would think that it's what matters the most.
Excellent point. We have another question from Daniel. For junior investigators, there are so many questions to ask in palliative care with big data. It's such a deep pool of complicated methods. Where might one start in a methodological, intimidating field?
That's a very good point. I guess the first step is to get an excellent training in epidemiology. The main threat to, as far as I can see, in using this type of data is because it is very easy to access them, and because it seems that it is very easy to make studies with them, is to go a little bit too fast and to design studies that are flawed. And we certainly have a lot of them published in the literature, and I guess in the next years we need to raise the bar in the quality of what all of us, myself included, of what we do. So I guess the first step is really to get an excellent training in epidemiology, because even if the data is there, one needs impeccable skills and training to actually make sense of these data. Otherwise, it's just going to remain sort of tables that don't make much sense. And the second step, I guess, would be to find a very good team of people who are experienced with the data. So one of the dangers of using big data is to believe that the same way survey data are very well documented, that these data come with no flaws, no defaults whatsoever. And it's, of course, wrong. And working with, for example, people from CMS who know the Medicare data by heart on the tip of their fingers is a real as a real added value. So I really cannot encourage you strongly enough to get in contact with the people who actually generate and curate the data. And that's one of the strengths of people like Miguel Hernan in Harvard, is that they're working very much hand in hand with the people who are responsible for this data, so that they can really spot weaknesses and strengths of the different data points that they have in their data sets.
That is such excellent advice. We have another question from Paul. Are single institution reviews of data much less useful than multi-site studies? There is often difficulty in obtaining data pulls and IRB OKs from multiple sites.
Yeah, here I'm afraid it's a bit difficult for me to answer, because these regulations vary a lot country by country, and that is, for example, a difficulty that we would not have in Europe, or at least in most Western European countries. So I'm afraid I'm of little help here.
I see. There's definitely differences between countries, as you mentioned. We have another question. How do you educate funding agencies that observational studies can be as rigorous as RCTs and actually might be the best approach given the population and research questions? There remains a bias towards RCTs.
Yes, absolutely. And here, this is where it doesn't vary so much by countries. So two ways. One is I would say a positive message is to try to demonstrate the value of doing it. And here, by doing it, most of these people only believe what they see. And so you have to show them that it actually works, that you can get meaningful and insightful findings out of it. We have now a very nice set of papers that have been published over the past 5 years, and that are really making at least my job easier when I want to convince funding bodies that we can do excellent work with this type of data. And the paper by Mike Steinman is one of them. So that's, I would say, the positive approach to it. Then there is a more negative, or trying to show that going for an RCT would be problematic. Well, if you prove that it's unfeasible, or that it's ethically unacceptable, and that therefore, even if it would have been the perfect approach, that approach is not accessible to you, and that the second best thing that you can actually do is big data, I think it's also a pretty powerful argument. So sometimes we would actually wish that we could do the randomized control trial, but we know we can't, either because it's not doable. For example, I'm working now on the causal effect of bereavement on the health of the surviving spouse. You can all imagine how that would be a highly unethical randomized trial. And here, the funding body, everyone is intelligent in these agencies. If you try to make a good case that, well, an RCT is by definition not doable, and that the only remaining option for you is big data, I guess they will be much more inclined to fund your study.
Excellent points. I'm sorry, did you want to add something to that?
I did not.
Oh, okay. We have another question. We lack palliative care research on vulnerable populations. Are there groups that will become further disadvantaged in the big data approach, reflecting on weapons of mass destruction?
I'm sorry, I lost you again there.
Are there groups that will become further disadvantaged in the big data approach?
Are we talking about groups of researchers or groups of patients?
Groups of vulnerable populations.
That's actually a risk. So one of the things that we have found while analyzing the 700 papers that have been published over the last 20 years is that the overrepresentation of young patients with cancer and Medicare covered patients over the rest is actually magnified in big data, mostly and almost only because of the availability of data. So one of the risks is that because we have this magnifying glass, we are actually amplifying the already problematic under coverage and under investigation of certain groups. That is, I would say, the half empty glass. Now, the half full glass is that we have more and more the possibility of looking at marginalized groups of patients. I was just reviewing a paper looking at homeless people, for example, in a large city. And that is something that would be very difficult to do with a survey, and routinely collected data is actually pretty powerful to investigate these populations. So there is a risk that we basically overdo the already ambiguous and problematic gap that we see in the literature, But at the same time, that could be a tool to try to rectify things and to make things a little bit more equal.
Excellent point. I see a few more questions came in through the chat and hand raise features. When writing a big data research proposal, to which extent the predictive analytics and machine learning techniques should be specified, given the fact that the use of big data is actually data-driven?
That's an excellent point. There is a kind of a myth nowadays that data-driven means uncontrolled or unsupervised, and especially in the context of end-of-life care, I think that is a highly non-recommendable approach. Because if you only let the computer run the numbers and crunch the numbers to try to predict some kind of events, there is a very serious risk of either reversed associations or reverse causation, or to simply overfit the data. That is, that the data that you have and that allows your computer to predict what happens to these patients can only do it with your own data. So it's of course not about trying to explain or to specify in a very detailed way how the computer is going to run the data, but rather trying to say what it is that you want to obtain as an output, and trying to explain also to the reviewers and the people who are going to grade your research proposal how you, as an expert, someone with field knowledge and content knowledge, how you will be supervising the models and the data analytics. Otherwise, and this is something that is popping up a lot right now in the literature, we will generate a lot of studies that are either completely meaningless in the sense that, well, they tell us things that are just in the data and not in actual beds, so they do not correspond to actual patients. Or the other risk is that what you report in the papers or in the research that you do is only valid for those people that were in your data set and not for anyone else in the world. And that is, of course, not something that I guess anyone wants to do.
Okay, thank you. And to add to that question, how would you convince the funding bodies of the rigor of the data-driven research and analysis?
Well, I guess it goes back to my previous points. I think first, showing that this is not a one-shot endeavor, and that you have expertise and experience in that field, because we are seeing now a lot of research proposals of people who want to go towards machine learning, and that's certainly a very good thing. But I guess more and more we want to see that people who are proposing that have the expertise and the resources to do so in a rigorous way. So I guess here experience is going to speak for yourself. And the second thing is, again, as I said, you need to show that you have the ability and the knowledge to supervise and to correct the model, so that if the model goes completely sideways, you can correct it, and that you're not blind to the meaning of what the output is trying to tell you.
Excellent point. We have another question from Executive Committee member Dr. Christine Ritchie. She asks, if you could choose 2 patient or caregiver questions to add to large studies, what would you choose?
So questions that I would add in a study, you mean?
Yes.
Well, I guess for the patients, what we are missing very often is something related to their preferences and to their worldviews towards the goals of treatments, etc. So I guess it would be a question related to that. And when it comes to the caregiver, I guess my main interest would be, after this end-of-life phase, how the caregivers perceive what happened at the end of life once their relative has died.
Excellent. And we have another question from Amy. Who are all the essential players to include for big data research?
That is, again, very country specific. I am personally not very inclined towards saying that, you have people that you cannot do without. I think even very close to you in pretty any major university now, you have very good researchers using this type of data. So my advice would be, try to look as close as you can to your own practice and research activity, because it's better to have a collaborator, I would say, close to you and with whom you can exchange on a very regular way. And then in the United States, so I guess Charlotta Lindvall, when it comes to natural language processing, is a very natural person to talk to. She's absolutely brilliant and very friendly, which is always a plus. And then you have all the people at Brown with Andrew Zullo, very interesting research. And then I guess Mike Steinman, I know Cynthia Boyd is also interested in these approaches. So I guess these are all very interesting people to talk to.
Great, thank you. That is excellent advice. If we don't have any more questions, let's hold for maybe just one more minute to see if any questions come in. And please do so through the Q&A feature. We have just a few more minutes until the top of the hour. And Connie would like to repeat, thank you so much for such a wonderful presentation. We really can't thank you enough, Lucas, for your expertise in big data.
Thank you very much. My pleasure.
Okay, thank you all for such great questions today. And thank you, Lucas, for your presentation as well. We also plan to send an evaluation via email to all those who participated in today's or attended today's webinar. It's just very quick, and I think it's just about 10 questions. We really appreciate your feedback. We also hope that you join us for future episodes in the Investigator Development Series. We have one coming up relatively quickly, November 4th, Increasing the Value of Palliative Care Research. And in December, we plan to host research funding opportunities for chronic pain management and serious illness. And then we'll be picking up one of our newest special interest groups in the PCRC. And I see that we came out right on 5 minutes early. Lucas, thank you so much. And I'm sure you're willing to answer any more questions that come your way, perhaps via email.
Absolutely. Please do not hesitate to send me an email or to contact me on Twitter. Thank you again for the invitation.
Great. Thank you so much, Lucas. And thank you all for attending. I hope you all have an excellent day.